Hello everyone. Today we are going to see few advancement in our audio video engineering. For example, we have started with the black and white television, then color television, then digital television, then high definition television. Apart from that, if you really want to enjoy the videos, then you have to further see beyond this HDTV and all these things. HDTV is normally give the resolution. Okay, four things which we have already seen as far as HDTV is concerned, that you have a resolution, good resolution. So three different resolutions are there. First resolution is 1280 into 720p. Second is 1920 into 1080i, and third is 1920 into 1080p. So the maximum resolution of HDTV is 1920 into 1080p. So this 1920 indicates 2K video. Okay, so as far as home TV is concerned, the maximum resolution with the help of this terrestrial broadcast or dish TV broadcast or satellite broadcast or cable broadcast is concerned, we are receiving 1920 into 1080p. So this 1920 resolution indicates 2K video. But now you are aware of 4K video, 8K video, 16K video, such a highest quality 32K video, such type of videos with the higher resolutions they are available, and you can further enjoy the video systems and video related qualities, and the details can be observed. So this is one thing about resolution. Then you have progressive scanning, then you have the different 5.1 system like left, right, center, rear right speakers, and accordingly audio excellence with the woofer effect, that is 5.1, then 7.1 top and bottom. All these audio excellences are also observed in such type of advanced television systems. Right now we are just aware of full HD, that is 1920 into 1080p, but the technology has gone very far, and more advancements are there, and you are aware of that 2K video is the 1920 into 1080p, that is full HD. But beyond that also 4K, 8K, 16K, 32K, and such type of projectors are also available nowadays in the market, which give you the very high resolution. So likewise, in this technological advancement, one more television is there, that is called as IP television. My friends, please don't mix up the concept of IP television and internet television. I will give you one example, and we will see the difference between IPTV and internet TV afterwards. But before that, please try to understand what is IPTV and what is the difference between IPTV and internet TV. Internet TV, the best example is YouTube streaming. Okay, try to understand. IP protocol is used, internet service is used from the service provider, but YouTube type of or few television channels which are available on content server and through streaming server, you can directly see this internet television on your PC or on your television. But then what is the main difference between this internet television and IPTV? IPTV requires a separate set-top box, and it is costlier. The service one-to-one internet service bandwidth minimum 5 Mbps constant is required for IPTV to watch a single channel. Try to understand. So 1920 into 1080p, such type of resolution can be seen uh, directly through the internet service. But this IPTV, this type of systems, they are funded by few funding agencies, whereas internet television is running on the different ads which are running while watching this YouTube and several other television channels. So we will see that internet television and difference between internet television and IP television after. But please keep in your mind that IPTV is different and internet television is different. IPTV is costlier and internet television is cheaper. IPTV has a control of service provider, IPTV service provider. No ads, no disturbance, and nothing can pop up whenever you are watching IPTV related things. But any ad and all these things can be pop up whenever you are watching internet TV. So let us see the fundamentals and the electronics and the networking behind this IP television. So let us start with television IP audio system. Whenever I am saying IPTV television, two different informations are there. One is audio and another is video. So let us start with typical IP audio system. So what is this? A microphone is there, which is the transducer. Whenever you talk, the compression and rarefaction of the air, they are converted into digital one, and this digital data is this sound information is converted sound information is converted into electrical signal. This electrical signal is given to this digitized and compressed section where the PCM modulation, that is pulse code modulation, is done. So A to D conversion is done. So digitized signal is available. Time stamping process, that is synchronization bits are added, and thereafter it is given to a packetizing section where the IP addresses and related control information, normally we call it as a headers, okay, they are added. So once again I'm telling you, sound information in the form of compression and rarefaction, whenever you talk, it is converted into electrical signal, equivalent audio signal in the range of 20 hertz to 20 kilohertz. If you consider the musical instruments also, normally men's speech is in the range of 110 to 8 kilohertz, and women's speech is 220 to 10 kilohertz. And if you are talking about musical instruments, if they are um, being played at a back end, then the range goes up to from 20 hertz to 20 kilohertz. So this audio analog signal is taken, A to D conversion is done. This is the digitize and compression. Then sync bits, synchronization bits. So it is also known as time stamping process is added. It passes through this time stamping process, or it is a synchronization bits are added, and finally given to the packetizing section where the data is taken, it is packetized, the header, that is control information, is added, and the data is sent in a packet switch network. So you are aware of packet switch network, there are two types, okay, datagram networks and virtual circuit packet switch network. So we will see this. So what type of network is being used for IP television? So normal a public internet network having a packet switching concept only used, and accordingly this packetized data is traveling towards this receiver end. So this packetized data is taken, so IP packet receiver is there, and accordingly IP depacketizing is done. Time sequence, the synchronization bits which were added, they are removed, and finally it is given to D2A converter, and that digitized data is converted into analog, and this analog audio signal is amplified further and given to the loudspeaker, where this transducer convert the equivalent audio signal, amplified audio signal, into sound back. So sound energy converted into electrical one. This is the first step. A to D conversion, synchronization bits are added, packetizing is done, send on a packet switch network, signal is received, IP depacketizing is done, sync bits are removed, D2A conversion is done, amplification for amplification is done, and given to the loudspeaker, which converts your audio signal into equivalent sound signal. So this is about typical audio IP system. So these are the details which you have already studied in your TE, that is source coding, that ADC, analog to digital conversion using PCM techniques and all these things. So what is done? The analog signal is taken, then A to D conversion is done, then whatever this sampled and hold process is there, this sampled signal is quantized, and finally it is represented with the binary number with the specific code, and that um, the binary code is available, then parallel to serial conversion is done, and after that the synchronization bits are added, the packetizing is done, and then it is sent to uh, a packet switching network. So all these things you have already studied in your TE&TC for source coding. Then the same concept is applicable for IP video system. Individual IP audio system we discussed in previous slide. Individually, we will see if video information is available from camera, Okay, then how it is going to process. And thereafter IPTV consists of two different signal, audio as well as video, and how they process uh, when you combine it. Okay, so let us say IP video system. A video camera is there. Okay, video camera, a colorplex composite video signal is available. You are aware of 0 to 5 megahertz colorplex composite video signal is there, and you are aware of what are the different components of pure video signal for every scan line. Then you have horizontal blanking pulse, horizontal sync pulse, vertical blanking pulse, vertical sync pulse, and vertical sync pulses, before which 5 pre-equalizing pulses, after which 5 post-equalizing pulses, then front porch, back porch, on back porch 8 to 10 cycles of color burst. Okay, so depending upon PAL, NTSC or CCAM, the colorplex composite video signal is available. So entire composite video signal is converted into digital. So analog to digital conversion is done. Then sync bits, that is time stamping process is done, and finally packetizing. So header information, that is control information, is added, and data is packetized. So this video data is packetized and sent on packet switching network. It is received at a receiver and depacketizing is done. Control information or header information is removed, and thereafter time sequence process, that is sync bits which were added, they are removed, and there it is given to digital to analog converter, where this digitized video signal is converted into analog one. So here you will get colorplex composite video signal, which is given to, let us say, your different types of interfaces. So different types of video interfaces we have already seen. So it is basically categorized in two forms, that is whether it is analog interface or whether it is digital interface. So just try to recall, if it is an analog interface, the first basic interface is RF interface. Then you have audio video interface. RF interface, modulated information is there. Which modulated information? Audio is FM modulated, luminance is AM VSB modulated, color signal is QAM modulated, with suppressed carrier and all those things. Okay, if it is a AV, baseband audio and baseband video interface is there. Then third, you will get um, VGA interface. Okay, then S video interface, then YPVPR, YCBCR, such type of component interfaces. So all these interfaces up to VGA interface, they are known as analog interface, and you can give it to your television. Okay, and then what are the different digital television interfaces are there? So we have already seen our laboratories and in your classroom also. I have already told you that DVI interface, that is digital video interface, and HDMI interface, these two interfaces are also available. So if it is DVI, it doesn't have a audio, only it is a digital video interface. And whenever you are talking about HDMI, high definition multimedia interface, it consists of digital video as well as digital audio. So with the help of single HDMI connector, audio and video, both the information is available, and with the help of that interface, you can directly give it to your television. So now you must have understood there are two types of information which is available in IPTV. Number one is IP audio, in number two it is IP video. Okay, so IP audio and IP video. Now I have explained you how it works and how at a transmission side it is processed and how it is processed at a receiver end. Now just try to recall, in second unit and third unit we have seen CCR recommendation 601, committee consultative international radio communication have defined CCR 601 digitization format for digital video. So analog signal, that is colorplex composite video signal, is taken and it is digitized according to CCR 601 recommendation, and different types of digital video formats which are available, that is 4:2:2, 4:2:0, 4:1:1, that is SIF, source intermediate format, 4:1:1, that is CIF and common intermediate format, and finally 4:1:1 QCIF, that is quarter CIF format. Accordingly, the bitrate is going to be different. So highest bitrate is 4:4:4, then 4:2:2 is less than that, then 4:2:0 less than this, 4:1:1 less than this. So the minimum bitrate and the minimum quality, you can say that it is QCIF format. In the maximum quality and the bitrate which is required after digitization is 4:2:2, whatever the formats which are mentioned over here. So the maximum quality, maximum bitrate, minimum quality, minimum bitrate is required for such type of a digitization format. But please don't forget, in oral exam, examiner may ask you that what digitization format and what standard you are going to refer for this digitization, that you should be able to answer that it is CCR 601 digitization format. Now one more concept is there that you have to learn, that what exactly this letterbox effect is. So let us say this entire um, picture is recorded with the help of high definition, that is 16:9 camera. But if you really want to see it on 4:3 aspect ratio television, then this information is going to be cut. So this is called as non-letterbox effect. So letterboxing process is not applied. So what is done, if you take this HD movie and directly observe on standard definition television, then information loss will be there. Okay, definitely, of course, no, 16:9 recorded video you are watching on 4:3, so there will be a loss of, video information. But this problem is removed with the help of letterbox effect. So what is done, the video is processed in a such a way that this image becomes smaller and the entire image is fit in this standard television, that is 4:3, standard television of 4:3. So where the image size is reduced but the image information is not cut. So 16:9 aspect ratio high definition voltage can be directly seen on standard television, that is 4:3, called as letterbox effect. Now, one more concept is required as far as a digital video compression is concerned, and it is related to digital video compression. So, what is the basic concept? N number of digital video compression techniques are there, but the basic is, see this. Let us say this is one image. See, video is number of frames of a single picture is being displayed in a second. So let us say 25 fps, 25 frames of the same picture is being displayed in a single second. That is what related to persistence of vision, and because of which these movies are possible or the television is possible. So let us say take one frame from that picture, frame by frame, first frame, second frame, third frame. So how this digital video compression means the size of the resulting video you are going to reduce after this compression. So what is happening with this digital video compression? Okay, you take first frame, digitize all lines and pixels. So whatever data is available, you take second frame, you do the digitization of all lines and pixel, and then compare the previous digitized frame with this second frame data, and comparing these digital images and calculate the difference. This calculated difference is further processed and given to a block where third frame details are taken. They are digitized all lines and pixel, and this and the previous one again compared for the difference. The difference is calculated and given to the next frame. Likewise, first frame, second frame, third frame, the difference between first and second frame is taken and given to the next block. The difference between second frame and third frame is taken and given to the next block. Likewise, whatever common things are there, they are not considered. That's why automatically, with less information, with less this, the maximum information can be compressed. Okay, so with the help of this digital video compression, the information um, content is going to be reduced. Okay, again there are different types, that is lossy compression, lossless compression, that we will discuss it afterwards. But try to understand the basic basic fundamental of digital video compression is like this. Now the different types of MPEG codec. Okay, there are two different groups. Moving picture expert group, okay, this is one of the group. Okay, they are dealing with this, let us say, animated GIF, then MPEG 1, MPEG 2, MPEG 4, MPEG 4 AVC, that is improved video, and thereafter the different versions. Likewise, in 4G communication also, different types of versions are there, LTE, LTA, LTA, and so versions are there. Likewise, this is one of the group, that is moving picture expert group, and different versions are there. And there is a competitor, that is ITU, for this MPEG codec. Okay, and they are developing their compression standards parallelly. So you might have heard about Edge ITU, that is this MPEG 1 and MPEG 2. Instead of that, H.261, H.262, H.263, and this MPEG 4 latest one can be compared with the H.264 advanced version. Okay, so MPEG is one group, those who are working on this video compression, and another group is working on this different versions like H.261, 262, 263, 264, like that. Okay, now introduction to IPTV. Internet Protocol Television is a system through which television services are delivered using the Internet Protocol suite over a packet switch network such as Internet, instead of being delivered through traditional terrestrial satellite signal and cable television formats. IPTV services may be classified into three main groups: live television, that is with or without interactivity related to the current TV show; then time shifted television, catch up TV replays or TV shows that was broadcast hours or days ago; start over TV, that is replace the current TV show from its beginning; and that is video on demand, so browse a catalog of videos not related to TV programming. Okay, so different types of IPTV are there, and we will see one by one. So this is what the introduction of IPTV. Next, so different types of IP television viewing devices. So it can be a direct IPTV, which is available in the market. Number two, a normal E&TC or PAL television with the CRT display is available, but you will have to go for this separate set-top box, IPTV set-top box. Then third option, multimedia computer is there with HDMI interface. You can directly enjoy this IPTV. Third is laptop and multimedia mobile phone, that is smartphone you can have, and you can communicate and you can receive this IPTV signal. So these are the different devices on which IP television can be viewed. Then how you are going to receive that IPTV signal? So a number of ways are there. So let us say different broadband access providers are there in a market. It may be a through power line communication. So coupling, decoupling devices are there with which you can directly receive this IPTV signal. Then a cable line, cable modem, through which you can directly receive IPTV signal. Then you have a telephone line through which DSL, ADSL, VDSL, okay, such type of high bitrate lines are there with which you can enjoy IPTV. You can enjoy this IPTV with the help of broadband wireless 3G WN also, and accordingly you can receive that signal and you can process it and you can record and enjoy this IPTV signal. Likewise, these are the different broadband access provider through which you can receive this signal and you can enjoy this IPTV. Now, today we will see this IP television system content flow. Individual IP audio we have seen, individual IP video we have seen, and now this is what the final version of IPTV, that how it is going to be processed. The same blocks are there. Video signal, this is colorplex composite video signal of 0 to 5 megahertz. Then audio from microphone. Okay, this is the camera which converts your picture information into a video signal of 0 to 5.5 megahertz or 5 megahertz. Then audio, whatever you talk, okay, whether it is men's speech, women's speech, or you are playing musical instruments, along with that, that sound information is converted into electrical signal of 20 hertz to 20 kilohertz. It is combined composite video signal along with audio. Okay, it is A to D converted. Digitized signal is compressed. After compression, sync bits are added and packetizing is done. After packetizing, it is going to be sent on a packet switching networks. From that packet switching network, you are going to receive that depacketizing is done. So packetizing, this header information or control information is added. It may be IPv4 or IPv6. So normally we refer IPv4, and this packetizing is done at a transmission. Accordingly, depacketizing is done at a reception. Then sync bits are removed, decompression is done, D2A conversion is done, and finally two different signals are available, that is audio and video. And just now 5 minutes before I told you that it may be a analog interface or it may be a digital interface. So whenever I'm talking about IPTV and its quality, so definitely digital interfaces are used, and those interfaces are nothing but HDMI interface. Okay, so as far as today's lecture is concerned and today's session is concerned, we will stop here. And if you have any doubt, you please ask me about this IPTV system content flow, and a related further technology we will see in another lecture. So once again, I'm going to revise it. So just go to first slide and have a revision. So it is very simple. So we started with this IP audio system, that is audio is taken, it is processed, packetized, depacketized, D2A converted, given to the speaker. This is typical audio system. Then how A to D conversion using PCM source coding technique is done, that I have explained you. Then IP video system, instead of audio, how video signal is taken, how it is processed, how it is transmitted, how it is received. So individual audio, individual video we have seen. Thereafter CCR 601 digitization format we have seen, that this for this format maximum bitrate and maximum quality is there, and for this minimum bitrate and minimum quality is there. Then letterbox effect I have explained you in detail. Thereafter digital video compression fundamentals, so what is the basic fundamentals behind the digital audio compression is there, that I have explained you. Thereafter there are two groups, that is MPEG group and H dot, that is IT group is there, those who are parallelly working on this video standards, and accordingly this MPEG 4 is developed by this MPEG group, whereas H.264 and related versions are being developed by ITU international standards, and both the bodies are running parallelly to do the advancement in this compression technology. And thereafter we have seen introduction to IPTV, what exactly IPTV is, and how the services, IPTV services, are classified in three different groups, like live television, time shifted television, and video on demand systems. Thereafter different IP television viewing devices we have seen. Okay, and thereafter the different broadband access providers, like power line modem through cable modem through ADSL modem through, or like 3G 4G through, you can directly receive. Only one condition is there, minimum 3 to 4 Mbps bandwidth is required. We will see how to calculate that bandwidth and why it is required, and if this bandwidth is committed bandwidth from the IPTV service provider. It is not an internet service provider, it is a IPTV service provider which take care of committed bandwidth and committed quality. And thereafter we have seen IPTV system content flow, how audio and video information is taken, A to D converted, and then it is digitized, compressed, sync bits are added, packetized, send on packet switching network, received, depacketized, sync bits are removed, decompressed, then D2A conversion, and with the help of video interface like HDMI interface, normally you can watch this IPTV and enjoy this quality of video. So today we will stop here, and the further session we will come see in next session. Okay, thank you very much.